Section 4.3, logarithmic functions, question number 6. Here we want to solve the logarithmic equation. The key to solving a logarithmic equation is to be able to identify the three parts of the logarithmic equation and convert it into exponential form. Here we have the equation that's written in the form of log base b of r equals t. So you can pick out the three parts of the equation. The first one being the base. The base b is equal to x. The next part is your argument. Exponent. Sorry. T is equal to the exponent. The exponent t is equal to 5. And then the last part out of the three that you can identify is the argument. R is equal to the argument. The argument R is equal to this fraction 1 over 3125. So R is equal to 1 over 3125. Anytime you can write an equation in logarithmic form that has three parts, you can convert it to exponential form. And exponential form, right here, this is logarithmic, we're going to convert it to exponential by taking and rearranging those three parts. B to the t is equal to r. And we go ahead and plug in what we know. B, our base is x, the exponent is to the 5th power, that equals r, which is 1 over 3125. Now we have an equation. It's a basic polynomial equation. X to the 5th is equal to 1 divided by 3125. We want to solve this equation for x. To get the x by itself, we want to raise this left side to a power that is a fraction that when we simplify, we get rid of that power of 5. The power that we're going to raise it to is going to be the reciprocal, 1 over 5. If you raise the left side of the equation to the 1 over 5 power, you have to do the same thing to the right side of the equation. Raise that to the 1 over 5 power. So the x to the 5th to the 1 over 5 power is simplifies because if you have a to the m raised to the nth power, the base to a power, you multiply those powers together, a to the m times n, and 5 times 1 over 5 is equal to 1, so that means we get x to the 1st power. And this next part, 1 over 3125 raised to the 1/5 power, you can use a calculator to evaluate that, or you can take the 5th root of 3125, which would involve some factoring out. All right, since our answer is 1 over 3125 raised to the 1/5 power, I'm going to use a calculator to simplify this. You can use a scientific or a graphing calculator. I'm putting the fraction 1 over 3125 in parentheses, closing that, and then I'm going to raise that to a power, and the whole power I'm going to put in parentheses 1 divided by 5 and close the parentheses. So I have this fraction 1 over 3125 all raised to the 1 over 5 power. And I enter, and I see the answer is 0.2. I can probably write this as just 0.2, or I can write it as a fraction, going to the math button on the graphing calculator and choosing number 1 to convert it to a fraction. So this answer I can write as 1 over 5. And check your answer. Okay, so again, the key to solving this logarithmic equation is to identify the three parts. Once you get those three parts, rearrange them into a new exponential equation and solve that equation algebraically. Let's look at number 7. Here we have a logarithmic equation that is x equals log of 4 raised to the log base 4 of 13. Now this is one of those properties that you'll find in your book that ends up simplifying. Now we can solve this by picking out the three parts of the exponential equation. Here we have a base b raised to an exponent t is equal to r. So our base b is equal to 4. Our exponent is t is equal to all of this, log base 4 of 13. And then r is the argument, which is in blue. Here we go. R is equal to x. This r is equal to x. We have this equation that's in exponential form. We're going to convert it to logarithmic form. We want to write this as log base b of r equals t. We have it in this form. We convert it to this form. Plugging in everything we know, we can write this as log. The base is 4. The argument r is x. That has to equal the exponent. The exponent is this entire log base 4 of 13. Now take a look carefully at this problem here. We can see that we have an equation that has a log on the left and a log on the right. The base on the left 4 is equal to the base on the right 4. The only things that are different about these sides of the equation is the x on the left and the 13 on the right. The log is the same, the base is the same, so the argument has to be the same. We can say x is equal to 13. It's actually the solution to this equation. X equals 13. Now this is a property of logarithms. In fact, there's a theorem in your book. It's in section 4.3 that identifies anytime you have a base raised to an exponent that's a logarithm with the same base of the argument, these are like inverses, they cancel out. So you can look at the original equation and say x is equal to 13. That may take some practice, so for now you can go through and look at the three parts and rearrange them into logarithmic form to solve the equation. Okay, let's look at number 8. For number 8, we have log base x of 64 equals negative 3. We want to solve the equation for x. The equation is in logarithmic form, and we want to convert to exponential form to solve the equation. Okay, it is already in the form of log base b of r equals t. We can pick out the three parts. b, the base is equal to x. The exponent t is equal to negative 3, and the argument r is equal to 64. We're going to now take those three parts of the logarithmic equation and convert it to exponential form to get the equation that looks like b to the t equals r. Again, we start off with logarithmic. We're going to convert it to exponential form. Let's plug in the values that we know. The base is x raised to the exponent negative 3. That has to equal the argument of 64. All right, here we have an algebra equation. We want to solve this equation for x. To do that, we're going to raise that left side of the equation to an exponent that would be a fraction that would end up simplifying this. This is a negative 3 power, so I'm going to raise it to the negative 1 over 3 power. And I'm going to do the same thing to the right side of the equation, raise it to the negative 1 over 3 power. And the reason why I chose that power is that when you simplify the equation, x to the negative 3 to the negative 1/3, that power to a power, you multiply those together and you get a power of 1. So x to the first power equals all of this. And we'll use a calculator to simplify this. I'm going to put my base 64, raise it to the exponent, and the exponent I'm going to put negative 1/3 in parentheses. Okay, and enter, I get 0.25, or you can convert that to a fraction, 1/4. So the solution to this equation is solving for x. X equals 0.25, or as a fraction, we can write it as 1 over 4. Let's check the answer. Excellent. And move on to question number 9. This question is in logarithmic form, and we want to solve the equation log base 5 of x equals 2. We solve this equation by converting from logarithmic form to exponential form. This is written in the form of, oops, this is written in the form of log base b of r equals t. Identify the three parts. B is the base, b is equal to 5. The exponent t is equal to 2. The argument r is equal to x. We're going to convert this now to b to the t equals r, rearranging those three parts of a logarithmic equation to get 5 to the second power equals r, which is x. So we have 5 to the second power equals x, that's 25 equals x, or we can write x equals 25. So we can solve the logarithmic equation by converting to exponential form and solving. Check our answer.